Assalamualaikum warahmatullahi wabarakatuh. I'm Devi Febrianti from Mathematics Education. We'll present a journal entitled Nature User Interface to Teach Math and Higher Education. Abstract: a common and chronic problem among students on higher education, in general throughout the scholar life, is the difficulty of learning math. Nowadays, the teaching method for learning math remain relatively the same, though with emerging of new technologies like portable devices, smartphone and tablets, and movement interaction devices, Nintendo Wiimote, Microsoft Kinect, and PlayStation Move. Learners and teachers have big interest on new way of interacting throughout the teaching-learning process. In this sense, the nature user interaction offers great potential to facilitate new way of computer and hand learning. These have the potential to enhance classroom interaction by increasing learner participation, facilitating the teacher presentation, and creating opportunities for discussion. We present a system that combines gesture and touch interaction to support teaching math across multiple personal devices and public display to enhance and support math education for college students. In a formative usability study, learners and teachers were positive about the interaction designs and the learners' possibilities for math education. Thus, they created good intention in the user of continuing using it. Keyword: learning technology, math education, nature user interface, human-computer interaction. 1. Introduction. Since education is closely linked to the creation of information and communication of knowledge, it is not surprising that information and communication technology present great opportunities in education. Because of its huge penetration, the first idea that comes to mind when thinking about ICT is perhaps the personal computer, in which the interaction occurs through devices such as the mouse, keyboard, and screens. Talking advice of the advances that have been made in the development of interface, tangible, gesture, auditory, and the release of programming tools for the Kinect sensor, and some additional libraries can facilitate the incorporation of the nature user interface to support teaching tools, to facilitate and expand its use by teacher and student. We can define new as tools that allow users to facilitate and expand its use by teacher and student. We can define new as tools that allow users to interact with systems in the same way they interact with the real world. 2. Background. The 2011 Horizon report mentioned that are 6 technologies to be used in universities for teaching, learning, research, and creative expression. Among them, gesture-based computing with an estimated time of adoption of 4 until 5 years. 3. Methodology. 3.1. Context of use. The context of use is determined as a result of a process of direct observation and interviewing those who could be potential users of the application. Mathematics teacher working with groups of different levels. 3.2. Designs. The designs come from the need felt by teachers, who for several years have taught and have experienced benefits and limitations of various tools used in the classroom. They suggest some points according to their experience. 3.3. Prototype. In the first prototype raises 2 different scenarios. The first one covers the topic of function, their identification and graphing. The second one covers algebra topics. 3.4. Evaluation. Once finished the first prototype, we proceeded to perform a preliminary evaluation with focus on the ease of use of the application and its user experience. For preliminary evaluation, A first prototype was created to test the reaction of students when a system with nature interaction is present to him, the way he might interact with it and see if it generates any interest in the user. We call this prototype made new. This is the picture prototype made new. For 1. Testing the first prototype. The potential advances of nature-user interaction cannot be perceived until they are situated in an interaction context. Preliminary evaluations are ideal mechanisms to go beyond correct practices and allow us to get involved in the design process and visualize new themes of application in a simple and economic way. To explore the feasibility of the conceptual designs, a preliminary evaluation was conducted testing the scenario of use and the prototype with 3 students from the School of Telematics of the University of Colima. See Picture 3. These evaluations were video recorded and photographed. The technology acceptance model was used, developed by Davis 1989, and the system usability scale for measuring usability Brock 1996. 25% of the students were men and 75% women. 100% are software engineering students. 66.6% of them said that they have not used systems with nature interaction. 5 results. 5.1 theme. The purpose of theme is to explain the causes of the acceptance of the technology by the user. Proposes that perception of usefulness and ease of use by an individual in an information system are conclusive in determining their intention to use the system. For the perception of ease of use, 80% believe that the system is easy to use, 60% agree it is easy to learn, while 40% strongly agree and 60% agree that it's clear and understandable. And finally, by 100% believe, agree and strongly agree that it's easy to find information on it. See Picture 4. In the area of the utility perception of the respondent, 60% believe that the system is efficient, 40% said it improved their performance, while 80% said it improved their productivity, and 80% believe that was useful. See Picture 5. Regarding the attitude towards the use, a positive response was untied for the system. 80% agree that it seemed a good idea. It's software. See Picture 6. Finally, the answer on the intended use, 80% of the users said they would use the system in their cases, use it again, and have the intention of use it. See Picture 7. 5 to SAS. The SAS is a simple 10-item scale giving a global view of subjective assessment of usability, has proved to be a robust and reliable evaluation and correlate well with the usability metrics. The result exposes a frequency of the distribution of such score showed in a Picture 8, from which we can infer that the platform evaluated at least in the system usability scale is going in the right way because 100% of the participants consider their needs certain funds with this platform between 61 and 100 points of certain function. Finally, conclusion. This work presents the creation of a new math learning system called MathNew at the University of Colima for learning mathematical concepts through the use of nature-user interaction. The evaluation of this platform gives as a result that the platform is useful and allows a greater performance and efficiency, and it is also considered a good idea. Thus, this created good intention in the student of using it again. As a general conclusion, we can say that the use of nature-user interface to develop math application for education is adequate. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.